Right, we're moving on to the next reaction of alcohols. In fact, there are two more that we need to do on the course. So we've obviously done combustion was number one, and oxidation was reaction number two. So we're on to number three, and it's called dehydration. And probably the name of that reaction tells you something about what's going to happen, as it's a word that is used more widely to do with lack of water. So if we look at the reaction that we need to know here, we can see here that if we start off with an alcohol, here we've just got propan 1-ol, we can convert it into an alkene. And if you look at the way that must have happened, is that in order to form this double bond here, the alcohol has lost its OH group, but it's also lost a hydrogen from the adjacent carbon. So the double bond is formed where the OH group was and on the carbon next door. That's where the double bond ends up. Okay, so if we've lost an OH group and a hydrogen, what we've lost is water. So plus H2O on the right hand side as well. Now that's actually quite a difficult reaction to achieve. It's not one that I would normally do in the lab with you, so you're not missing out on anything there. The conditions are that you have to heat it to quite a high temperature actually. So heat under reflux, you don't need to know the temperature, but it's about 300 degrees C, I think I remember. But as I say, you don't need to remember the temperature. It also needs a high pressure as well, but I haven't written that down because that's not a syllabus sort of fact that you need to recall. But you do need to recall that it needs a concentrated acid catalyst. Typically that would be sulfuric acid or phosphoric acid. Again, concentrated acids like that are not very nice to be dealing with in the lab, particularly when you're refluxing them at high temperature. So as I say, not one that I would normally do as a practical. If you're asked for the type of reaction here, you can call it dehydration, that's absolutely fine, but if you remember those types of reaction that we mentioned a while ago, like addition, elimination, substitution, you should recognise that this one is elimination, because remember the feature of an elimination reaction is that you're starting off with one reactant but ending up with more than one, usually two, but more than one product. Now depending on where the alcohol group is on the carbon chain in the first place, there is the possibility of forming different products here. So if we have an alcohol rather, where the OH group is sort of somewhere in the middle of the molecule, like this one, you can see here that we've got butan 2-ol. Now if we look at that and we think, okay, well, I've got to do this elimination reaction, lose water from this alcohol. Well, we could lose we know we've got to lose the OH group, and if we lost the water by losing the OH group with the hydrogen on this side, then the double bond is going to end up here. So we would end up forming this product, but1-ene plus water. But the other possibility here is that this OH group could be lost, but it could also be lost by the molecule losing the hydrogen to the other side of it, in which case the double bond is going to be in a different position in the product. So you can see there that if this happens, then the double bond ends up here. So we've ended up forming but2-ene rather than but1-ene, and water obviously. Now, of course, not all alcohols will do this. The one we had up the top here when the OH group was on position 1 only has one possible product, but depending on where it is on the chain, this is a possibility. Now, we don't need any mechanism for this reaction, so I'm not going to draw curly arrows or anything like that. That's not required for this one, and you don't have to explain which one of these would form in the greater amounts. Okay, in fact, it's actually fairly random, and often you can't predict which one is going to form in the greater amounts. So it's not like the other reactions we've had where we've had a major and a minor product and you've had to explain that in terms of the mechanism. Nothing like that here. You just have to know what the reaction is, know what the conditions are, and realise that you've got this possibility of different products. Okay, fourth and final reaction of alcohols is a substitution reaction. So remember that when we've talked about types of reactions, substitution reactions are the ones where you're starting off with two reactants and ending up with two products. Something in the main part of your organic molecule, an atom or a group of atoms, is replaced with a different atom or group of atoms. And in this reaction, what's happening is an alcohol. So again, here I've just taken a nice simple alcohol, butan-2-ol. And an alcohol can be reacted with a hydrogen halide. I've chosen hydrogen bromide there, but it doesn't have to be. It could be hydrogen iodide, hydrogen chloride, or even hydrogen fluoride, although that tends to happen more rarely. Any hydrogen halide. And what happens is the OH group is replaced with the halogen. Okay, and again, water is the other product. No mechanism, again, required here. So nice in terms of what you've got to recall and remember. You just have to know the reactants and the products. But again, you need to know what the conditions are. So what you do usually with this reaction is you don't have sort of a bottle of the hydrogen halide. They're not very nice substances to deal with. So usually what you do is you form this kind of in situ. So you form it kind of as the reaction is happening, or just before you want the reaction to occur. So what you do is you have the sodium halide instead. That's a much nicer substance to have on your chemical store shelf rather than the hydrogen halide. So you have, pots of sodium halides, and you react those with sulfuric acid, and this forms the hydrogen halide, and then as soon as that's formed, it's then able to react with the alcohol. Okay, so that's just the extra little bit of detail really you need in that reaction. And that is it for our reactions of alcohols.